Now, in the past, a number of individuals believed that the way to solve the problem is to put in some debugging assert macros. In order to use it, one needs to include the header file cassert, or in the old days, assert.h. Now, what the assert macro does is it says, when it gets to this point in the code, assert that a must always be not equal to 0 in order for us to continue to run. If it is 0, an assert throws an exception and we trap it and the program stops. Then we'll go ahead and calculate the determinant, but then assert that this calculated determinant has to be greater than or equal to 0. If it isn't, debugging stops at once with an assert failure. Let's see how this works out. I'll enter my valid ones, 1, minus 1, and minus 2, and that one still works. Now let's enter the 0, 1, and 2. Whoa, we've got our assert failure, and at this point the program stops. It is asserting up here that a is not equal to 0, and it is equal to 0, so the assert fails and we're done. So the assert people say this is wonderful, this is what you should do in all cases, checking for errors. Wrong. Let's take this one step further. We've got the asserts in there. We know when there's trouble, we'll put it into production. Now let's see what happens when we put it into production. We'll enter our good value first, 1, minus 1, minus 2. All looks wonderful. Now we'll put in 0, 1, and 2. Boom! We're right back to production runtime crashes found by your users. This is no good. That's why the assert macro isn't a recommended procedure. Why? Because it only works in debug mode. It will not work in your production version. So, ounce of prevention. If there is a situation in your function, in your program, in your code somewhere that could spell trouble at runtime in production, then for heaven's sakes, it warrants an actual test.